Okay, so hello everyone. Today we will be solving Leetcode's POTD, which is count total number of colored cells, and the question number is 2579. Okay, the problem is marked as medium. So now let's see what the problem is all about. Let's read the description first. There exists an infinitely large two-dimensional grid of uncolored unit cells. You are given a positive integer n, indicating that you must do the following routine for n minutes. Okay, so we are given with an infinitely large 2D grid. Okay, so we need to perform some operations for n minutes, as the question says. Now let's see what the operations are. At the first minute, color any arbitrary unit cell blue. Okay. Every minute thereafter, color blue every uncolored cell that touches a blue wall. Okay. Below is the pictorial representation of the state of the grid after 1, 2, and 3 minutes. Okay. So let's see. At first, n equal to 1. So this grid is colored. At n equal to 2, first this grid was colored, then the adjacent grids were this, 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 and this. Okay, so in total 5 grids were colored in 2 minutes. Like, just a second, here are the 5 grids. Okay, so for n equal to 3, let's see. At n equal to 1, this will be covered. N equal to 2, this, 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 and this. Okay, just a second. This will be covered. This will be covered. This and this. At n equal to 1, this was covered, and n equal to 2, this, and this. Okay. So at n equal to 3, this will mark this, this, and this. This will mark this, this, this way. Okay, so in total, how many grids are colored? Like if we count it, it will be like 1, 5 here, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so as you can see, just a second. Okay, so in total, 13 grids were covered in 3 minutes. Okay, so here are the constraints. Now let's try to solve it. This question is actually observation based. If you can observe things, like you can identify the pattern, this question is easy to solve. Okay, so now let's start. Okay, so here we have n equal to 1, we have this grid. At n equal to 2, this will mark this, 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 and this. Okay, so these will be marked at n equal to 2, and then we will be having something like this. We will be having something like this at n equal to 2. Then we will, for n equal to 3, this will be colored. The outer ones will be covered for n equal to 3. Okay, then for n equal to 4, we will have this, like n equal to 3, we will be having this, and for n equal to 4, this will be marked, right? Because we are marking in which directions? Like we are marking in 4 directions. Okay, so at every second, every minute, it expands. Okay, so now let's try to identify the pattern. For n equal to 1, we have one grid colored. Okay. For n equal to 2, we had 1, plus 4. Okay, then for n equal to 3, like here we can see 1, this one came from here, right? Okay, so for n equal to 3, we have 1 plus 4 plus 8. Okay, so where this 1 plus 4 came from here, right? And this one came from here. Okay, so now let's move forward. At n equal to 4, we have 1 plus 4 plus 8 plus 12. Okay, in which 1 plus 4 plus 8 came from here, here as you can see. And how in this 1 plus 4 came from which side? This side, right? And 1 came from this. Okay, so if we can just identify the pattern, like here we can say 1 plus 4 into 0 something, which will be what? Into 0, which is 0, so answer is 1. Like from here we can observe that 4 can be written as 4 into 1, right? This 1 plus 4 into 1, 8 can be written, can 8 be written as 4 into 2? Yeah, we can write it. Okay, so here 4 can be written as 4 into 1, 8 can be written as 4 into 2, and 12 can be written as 4 into 3. Okay, so I think we got our pattern. What's the pattern? The pattern is like we will be start from n equal to 1 in all the cases, right? So how far we will go? We will go to n minus 1, right? We are going till n minus 1 because n equal to 1 and 2 minus 1 is 1. Like here we can see we went to like n equal to 3, and what n minus 1 is 2. So how far did we go? We go for 4 into 1 plus 4 into 2 and this one, right? In the below we can see that n equals to 4. How far did we go? We go for 4 into 1, 4 into 2, 4 into 2, 4 into 3. Okay, so that's our solution. Okay, as you can observe, like if we just do the, I would say, try run, it's very easy to code, right? It's completely observation based. So now let's see the code. So here is a code. Okay, it's a very easy one. So like we have at answer we have 0. We are starting from I equal to 1. Okay, because like if n equal to 1, we will simply return this one. And rest what we are doing, we are just adding answer and how many times the 4, the like I into 4, and we're just adding it to the answer and returning it. Okay, so the code is very easy, and the solution is, as you can see, the solution is also optimal. So yeah, that's our approach, and you will be able to find the code link in the description very soon, where I will also give the question link also. So once the verification is done. So yeah, that's all for the solution, and that was our POTD. So okay, have a nice day ahead.